What's poppin', biologists? Welcome back. We're going to be doing some amino acid Mondays. We're going to be starting with valine. So valine is another non-polar amino acid that has a relatively short side chain compared to some other ones. Let's draw it out here. So if you remember leucine, it's quite similar to leucine. Instead of having an isobutyl group, it has an isopropyl group as its side chain. So this is the isopropyl group here. I'll write that down. It's propyl because it's got 3 carbons, and yes. So its IUPAC name is 2-amino 3-methyl butanoic acid. Let's go through this because I know you all love IUPAC names. We've got 1, 2, and 3, and 4. So the first carbon is 1 on the carboxylic acid group. So on the second carbon, we've got an amino group, and on the third, we've got a methyl group, hence the name. So this is an essential amino acid. I'll put this here. And what I will say is its other names, so it can be also written as just V as its 1-letter amino acid code, or it can be written as VAL as its 3-letter amino acid code. And in terms of codons, so it's I guess the standard genetic code, it's the GU codons that code for it. So these codons are GUG, GUA, and GU, like that. Okay, let's move on to tryptophan now. So tryptophan is pretty chunky boy. It's a very chunky amino acid, and I know I've used the word chunky to describe other amino acids, but in this case I actually mean pretty fat. So tryptophan's 1-letter code is W, or it can be written as just trip, and we're going to draw out the display formula for this guy instead of the kind of like normal way that it's written with its kind of skeletal structure. I don't know why, I just prefer writing out all of the carbons, and really just helps emphasize the structure for me, but that's just me. So we're going to write out this structure. We'll also use the benzene ring. Well, we're going to draw the benzene ring in this kind of like weird way that you might not usually see it as, but it is a benzene ring, I promise. So a lot of people do actually call tryptophan. Tryptophan is an aromatic amino acid, but the reason given is because it has this benzene ring. Let's just draw it here. So this is the benzene ring here. That was 1 and 2, but it actually has another aromatic aspect, which is the pyrrole group here. So this ring here is a pyrrole ring. Now the reason why these both are aromatic is because they both obey Huckle's rule. So I'm going to give a quick refresher of Huckle's rule just in case you needed one. So Huckle's rule is basically 4n plus 2. It's the idea that any system, any planar system that satisfies this equation, its pi electrons will satisfy this equation, with n being basically an integer. So I'll just showcase what I mean by that. So in this benzene ring, you can see that we've got 3 double covalent bonds, and these bonds here, as you may already know, they're distributed evenly between all of the all the carbons in the system, and these delocalized pi electrons basically, you know, the double bonds here have a sigma and a pi, and in the pi bond there are 2 electrons each. So in this case we've got 2 electrons in this one, we've got 2 in the other one, and we've got 2 in the other one, so that's 6 altogether. So that's 6 pi electrons. So if we put 6, we set this equation to equal 6, we know that n equals 1. So because n equals an integer, then we know that this system is aromatic. So the same thing is with the pyro group. So the pyro group is very similar. You can see that this the benzene rings kind of section here, this too can actually be used in the pyro group. And we also have another load of guys here, 2 little electrons there. And we've only got 4 so far, but we can actually bring in a lone pair from the nitrogen and incorporate the lone pair into the delocalized electrons. So that means 6. So like as shown earlier, if we equal it 6, you'll get n equals 1. So they're both they're both aromatic rings. Okay, that was a bit of a tangent, but it is also an essential amino acid for tryptophan, so like valine in that sense. And its codons is actually just 1 codon, and that codon is the UG codon. UG. Ooh. UG. Cool. So just like methylene, methylene and tryptophan are the only 2 amino acids to be coded by one codon, I believe. So there's that. And if you didn't know, tryptophan can be used as an antidepressant. This is because it can be converted into serotonin in the body, and as you know, serotonin is that juicy neurotransmitter that everyone talks about. Okay, so lastly, I'll just say this: it's important for glycan protein interactions. You'll see this come up a lot in that regard. And yeah, there we go.